Through this example, we'll try to learn how to find the Laplace transform of, let's say, any polynomial function. So on this example, we have given this polynomial function as a 4t cube minus 3t square plus 7t plus 1. And then we would like to use some of the properties of the Laplace transform, and then we want to figure out the Laplace transform of this, okay, rather than just following the definition of the Laplace transform. We just want to use the property. Okay, so let's try to find the Laplace transform of this given function. So what do you need here to figure out the Laplace transform? If you look into here, each term of this polynomial function is so to find the Laplace transform of this polynomial function, what you can do here is figure out the Laplace transform of each of these terms and then add or subtract, and then that works because the Laplace transform satisfy the linearity property, like what you could do on the derivative and then the integral or something like that, right? So we could also do on the Laplace transform. So let's try to focus on each and every term over here. So let's just try to see what is the Laplace transform of this 4t cube, right? And then after that find the and then minus find the Laplace transform of, let's say, 3t square, right? So we can find that, and then plus just try to see what is the Laplace transform of 7t, and then plus just try to see what is the Laplace transform of 1. So this is how we could actually find the Laplace transform of each of those terms and add or subtract. All right, so how do we figure out the Laplace transform of, let's say, 4t cube? Then 4 is a constant, multiply by t cube. So to find the Laplace transform of this, what we can just do here is actually take the 4 out and then multiply that 4 with the Laplace transform of t cube. So that's what we could do, and that holds for each and every other term. So if you have a constant multiply by some function, so we could use the constant multiple rule like on the derivative and the integrals. So over here, then on the next term, we could take then 3 out and just try to multiply by that 3 to the Laplace transform of t square. On the next one, we can take 7 out, or let's say 7 multiply by the Laplace transform of t, and then at the end we could just try to figure out what is the Laplace transform of 1. Okay, so we could do that. All right, so I just tried to break down in this way, but now you realize that it looks like to find the Laplace transform of this polynomial function, our goal is just to see what is the Laplace transform of t cube, t square, t, and then 1. And then all of these can be figured out by this formula over here. Let's say we know by looking in the table of Laplace transform of 1 is actually just 1 over s, and then the Laplace transform of the t to the power n can be figured out by n factorial divided by s to the power n plus 1. Okay, so we can use this formula. Okay, all right, so let's try to use that. Then what we have over here is 4 multiplied by Laplace transform of t cube, so 4 times because of this formula over here. So this is this is the formula for the finding the Laplace transform of t to the power n, right? And then here is we have t cube, so I think we can use that formula. And then if you look, compare with t cube with t to the power n is kind of what, 3. So if that is the case, plug that into this formula. So what we will have is 3 factorial over s to the power 3 plus 1, so just 4, right? And then minus 3 times Laplace transform of t square will be 2 factorial divided by s to the power 2 plus 1, so cube, right? And then plus 7 times Laplace transform of t, that means n is 1, so 1 factorial over s to the power 1 plus 1, so 1 factorial is 1, so 1 over s is square, right? And then plus Laplace transform of 1 is, you could say, just 1 over s, or you could also feel that is like what, t to the power 0, so 0 factorial over s to the power 0 plus 1, so which is basically something we can say just 1 over s. That's it. That's the Laplace transform. Our job is just to see if we can actually combine or simplify. 3 factorial over here. 3 factorial means 3 times 2 times 1, so 6. 6 times 4 is what, 24, so 24 over s to the power 4. And then minus 2 factorial is 2 times 1, so 2 times 3 is 6, so 6 over s cube plus 7 over s square plus 1 over s is the Laplace transform of the given function. So this is how we can figure out the Laplace transform of actually any polynomial function. So just try to figure out the Laplace transform term by term, right? And then after that, I mean, just add or subtract, that's it. So this is how we could figure out the Laplace transform. For example, let's say if your goal is to figure out the Laplace transform of a polynomial, let's say function 2t square minus 4t plus 7, then what you just need to do is try to figure out the Laplace transform term by term. So 2 times over here 2 times t square, over here 4t, over here 7. So just figure out the Laplace transform of each of those. So for example, for the first term, this will the Laplace transform of 2t square will be 2 times Laplace transform of t square. So by using this rule over here, we can actually figure out the Laplace transform of t square, right? So which is 2 factorial over s to the power 2 plus 1, so s cube, minus 4 times 1 factorial over s to the power 1 plus 1 would be 2, plus 7 times 1 over s, right? So that's the Laplace transform. So we have then 4 over s cube minus 4 over s squared plus 7 over s. So this is how you can always figure out the Laplace transform of any polynomial function. So on this example, we had given 4t cube minus 3t square plus 7t plus 1. So you can look into here, and then this is the Laplace transform of that given function.